Hello viewers, welcome to our channel Career Prep. In this video, we'll solve a few problems on the topic combination. Permutation and combination forms an important portion in competitive exams like SSC, UPSC, railways, banking, etc. Since questions based on this topic are most frequently asked in competitive exams, it makes sense to understand the concept well. Questions on combination are dealt with in this video along with clear explanations to make you understand the topic easily. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. In how many ways can 4 members be selected from a group of 10 members? Here you are given 5 options and you have to find out which of these options is the correct one. So it's given that the total number of members is 10 and 4 members have to be selected from these 10 members. So the number of ways of selecting 4 members out of 10 members is 10C4. Now we can solve this problem using the formula method. Now according to the formula, 10C4 is equal to 10 factorial divided by 4 factorial multiplied by 10 minus 4 factorial, which is nothing but 10 factorial divided by 4 factorial multiplied by 6 factorial. Now 10 factorial can be written as 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 factorial, so that the 6 factorial in the numerator and the 6 factorial in the denominator can cancel out. And on solving this, we get the answer as 210. Now the value of 10C4 can also be found using the shortcut method. Here starting with 10 in the descending order, there has to be a multiplication of 4 numbers and this has to be in the numerator. So 10 multiplied by 9 multiplied by 8 multiplied by 7 is in the numerator, and in the denominator it is 4 factorial because 4 is the subscript here. Now on solving this, we get 210 as the answer. So there are 210 ways of selecting 4 members from a group of 10 members. So the correct answer is option C, 210. A boy has 9 trousers and 12 shirts. In how many different ways can he select a trouser and a shirt? Here you are given 5 options and you have to find out which of these options is the correct one. So here the boy has to select a trouser and a shirt. This means he has to select one trouser and one shirt. Remember that and means multiplication. So the boy can select one trouser from 9 trousers in 9C1 ways, which is nothing but 9 ways. The boy can select one shirt from 12 shirts in 12C1 ways, which is nothing but 12 ways. So the number of ways in which the boy can select one trouser and one shirt is 9 multiplied by 12, which is 108 ways. So the boy can select one trouser and one shirt from 9 trousers and 12 shirts in 108 ways. So the correct answer is option D, 108. A committee has 5 men and 6 women. What are the number of ways of selecting a group of 8 persons? Here you are given 5 options and you have to find out which of these options is the correct one. So it's given that a committee has 5 men and 6 women. So the total number of persons in the committee is 5 plus 6, which is 11. Now you have to select a group of 8 persons from these 11 persons. So the number of ways of selecting a group of 8 persons from 11 persons is given by 11C8. Now 11C8 is nothing but 11C 11 minus 8. 11 minus 8 is 3. So 11C8 is equal to 11C3. Now we can find the value of 11C3 either by the formula method or by the shortcut method. Now according to the formula, 11C3 is nothing but 11 factorial divided by 3 factorial multiplied by 11 minus 3 factorial, which is nothing but 11 factorial divided by 3 factorial multiplied by 8 factorial. Now 11 factorial can be written as 11 multiplied by 8 multiplied by 9 multiplied by 8 factorial, so that the 8 factorial in the numerator and the 8 factorial in the denominator get cancelled out. And on solving this, we get the answer as 165. Now using the shortcut method, the value of 11C3 will be starting from 11 in the descending order. There has to be a multiplication of 3 numbers and this has to be in the numerator. So 11 multiplied by 10 multiplied by 9 is in the numerator, and in the denominator it is 3 factorial because 3 is the subscript here. Now on solving this, we get the answer as 165. So there are 165 ways of selecting a group of 8 persons from a committee of 5 men and 6 women. So the correct answer is option A, 165. A committee has 5 men and 6 women. What are the number of ways of selecting 2 men and 3 women from the given committee? Here you are given 5 options and you have to find out which of these options is the correct one. So a committee has 5 men and 6 women, and you have to select 2 men and 3 women from this committee. So the number of ways to select 2 men from 5 men is 5C2 and means multiplication. The number of ways to select 3 women from 6 women is 6C3. Now let's find out the value of 5C2 multiplied by 6C3. Now according to the formula, 5C2 is nothing but 5 factorial divided by 2 factorial multiplied by 5 minus 2 factorial, which is 3 factorial, multiplied by 6C3 is nothing but 6 factorial divided by 3 factorial multiplied by 6 minus 3 factorial, which is 3 factorial. Now 5 factorial can be written as 5 multiplied by 4 multiplied by 3 factorial, so that the 3 factorial in the numerator and 3 factorial in the denominator can be cancelled. And on solving this, we get 10 multiplied by 6 factorial can be written as 6 multiplied by 5 multiplied by 4 multiplied by 3 factorial, so that the 3 factorial in the numerator and the 3 factorial in the denominator can be cancelled out. And on solving this, we get 20. So 10 multiplied by 20 is 200. Now we can find the value of 5C2 multiplied by 6C3 using the shortcut method. Now 5C2 is equal to 5, starting from 5 in the descending order, there has to be a multiplication of 2 numbers and this has to be in the numerator. So 5 multiplied by 4 is in the numerator, and in the denominator it is 2 factorial because 2 is the subscript here, multiplied by the value of 6C3 can be found out. Starting with 6 in the descending order, there has to be a multiplication of 3 numbers and this has to be in the numerator. So 6 multiplied by 5 multiplied by 4 is in the numerator. 3 factorial is in the denominator because 3 is the subscript here. Now on solving this, we get 10 multiplied by 20, which is 200. So there are 200 ways of selecting 2 men and 3 women from the given committee of 5 men and 6 women. So the correct answer is option B, 200. In a class, there are 20 boys and 25 girls. In how many ways can a boy and a girl be selected? Here you are given 5 options and you have to find out which of these options is the correct one. So here you have to select one boy and one girl from 20 boys and 25 girls. So one boy can be selected from 20 boys in 20 C1 ways, which is 20 ways. One girl can be selected from 25 girls in 25 C1 ways, which is 25 ways. So the number of ways of selecting one boy and one girl is 20 multiplied by 25, which is 500 ways. Now you can solve this problem using the formula method or the shortcut method. Now let's look at the formula method first. Now you can select one boy from 20 boys in 20 C1 ways and is multiplication, and you can select one girl from 25 girls in 25 C1 ways. Now you can find the value of 20 C1 multiplied by 25 C1 using the formula. So according to the formula, 20 C1 is equal to 20 factorial divided by 1 factorial multiplied by 20 minus 1 factorial, which is nothing but 19 factorial, multiplied by 25 C1 is nothing but 25 factorial divided by 1 factorial multiplied by 25 minus 1 factorial, which is 24 factorial. Now 20 factorial can be written as 20 multiplied by 19 factorial, so that the 19 factorial in the numerator and the 19 factorial in the denominator gets cancelled out and we are left with 20. Multiplied by 25 can be written as 25 multiplied by 24 factorial, so that 24 factorial of the numerator and the 24 factorial of the denominator gets cancelled and we are left with 25. So 20 multiplied by 25 is 500. Now we can find the value of 20 C1 multiplied by 25 C1 using the shortcut method also. Now 20 C1 is nothing but, starting with 20 in the descending order, there has to be a multiplication of one number and this has to be in the numerator. So in the numerator it is 20 and in the denominator it is 1 factorial because 1 is the subscript here, multiplied by 25 C1. 25 C1 is nothing but 25 in the descending order, there has to be a multiplication of one number, so 25 in the numerator, divided by 1 factorial in the denominator because 1 is the subscript here. So now we have 20 divided by 1 factorial multiplied by 25 divided by 1 factorial. We know that 1 factorial is 1. So we get 20 multiplied by 25, which is 500. So there are 500 ways of selecting one boy and one girl from 20 boys and 25 girls. So the correct answer is option B, 500. A committee of 5 persons is to be formed from 6 men and 4 women. In how many ways can this be done when at least 2 women are included? Here you are given 4 options and you have to find out which of these options is the correct one. So here a committee of 5 persons is to be formed from 6 men and 4 women, and the committee should consist of at least 2 women. At least 2 women means a minimum of 2 women should be in the committee, and since there are 4 women, the maximum number of women in the committee is 4 women. So when at least 2 women are included, the committee of 5 persons may consist of 2 women and 3 men, or 3 women and 2 men, or 4 women and 1 man. Remember, or means addition. Now let's look at the first case where 2 women and 3 men can be selected. Now 2 women can be selected from 4 women in 4C2 ways, and means multiplication. 3 men can be selected from 6 men in 6C3 ways. Now 4C2 is nothing but 4, starting from 4 in the descending order, there has to be a multiplication of 2 numbers, and this has to be in the numerator. So 4 multiplied by 3 is in the numerator. 2 factorial is in the denominator because 2 is in the subscript here. Multiplied by 6C3, which is nothing but starting from 6 in the descending order, there has to be a multiplication of 3 numbers, and this has to be in the numerator. So 6 multiplied by 5 multiplied by 4 is in the numerator. 3 factorial is in the denominator because 3 is the subscript here. Now we know that 2 factorial is 2 and 3 factorial is 6. So on solving this, we get 6 multiplied by 20, which is 120. Now let's look at the second case where 3 women and 2 men can be selected for the committee. Now 3 women can be selected from 4 women in 4C3 ways, and is multiplication. 2 men can be selected from 6 men in 6C2 ways. Now 4C3 is nothing but 4 multiplied by 3 multiplied by 2 divided by 3 factorial, multiplied by 6C2, which is 6 multiplied by 5 divided by 2 factorial. We know that 3 factorial is 6 and 2 factorial is 2. On solving this, we get 4 multiplied by 15, which is 60. Let's look at the third case where 4 women and 1 man can be selected for the committee. Now 4 women can be selected from 4 women in 4C4 ways, multiplied by 1 man can be selected from 6 men in 6C1 ways. Now 4C4 is nothing but 1 and 6C1 is nothing but 6. So 1 multiplied by 6 is 6. Now we have found out that the committee of 5 persons may consist of 2 women and 3 men, and this can be formed in 120 ways. Or the committee of 5 persons may consist of 3 women and 2 men, and this can be selected in 60 ways. Or the committee of 5 persons may consist of 4 women and 1 man, and this can be selected in 6 ways. So the total number of ways of forming the committee is equal to 120 plus 60 plus 6, which is 186. So there are 186 ways of selecting a committee of 5 persons from 6 men and 4 women when at least 2 women have to be included. So the correct answer is option B, 186. The Indian cricket team consists of 16 players. It includes 2 wicket keepers and 5 bowlers. In how many ways can a cricket 11 be selected if we have to select 1 wicket keeper and at least 4 bowlers? Here you are given 5 options and you have to find out which of these options is the correct one. Now it's given that the total number of players in the Indian cricket team is 16. Number of wicket keepers is 2 and number of bowlers is 5. So the remaining number of players is 16 minus 2 plus 5, which is 7. So 16 minus 7 is 9. So the remaining number of players is 9. Now 11 players have to be selected, which includes one wicket keeper and at least 4 bowlers. Now at least 4 bowlers means a minimum of 4 bowlers have to be selected. Now since the number of bowlers is 5, the maximum number of bowlers that can be selected is 5. So now the 11 players can be 1 wicket keeper, 4 bowlers and 6 other players, or the 11 players can be 1 wicket keeper, 5 bowlers and 5 other players. Remember that OR means addition. Now let's look at the first case. The number of ways of selecting 1 wicket keeper, 4 bowlers and 6 other players. Now 1 wicket keeper can be selected from 2 wicket keepers in 2C1 ways and is multiplication, and 4 bowlers can be selected from 5 bowlers in 5C4 ways and is multiplication, and the 6 other players can be selected from the remaining 9 players in 9C6 ways. Now 9C6 can be written as 9C 9 minus 6, which is 3. So 9C6 can be written as 9C3. Now 2C1 is nothing but 2. 5C4 is equal to 5 multiplied by 4 multiplied by 3 multiplied by 2 divided by 4 factorial. 9C3 is equal to 9 multiplied by 8 multiplied by 7 divided by 3 factorial. Now here the 4 factorial in the denominator and 4 multiplied by 3 multiplied by 2 in the numerator gets cancelled and we are left with 5 here. Now we know that 3 factorial is 6 and on solving this we get 84. So now we have 2 multiplied by 5 multiplied by 84, which is 840. Now let's look at the second case. The number of ways of selecting 1 wicket keeper, 5 bowlers and 5 other players. Now here the 1 wicket keeper can be selected from 2 wicket keepers in 2C1 ways and is multiplication. 5 bowlers can be selected from 5 of these bowlers in 5C5 ways and is multiplication, and the rest of the 5 players can be selected from the remaining 9 players in 9C5 ways. Now 9C5 can be written as 9C 9 minus 5, which is 4. So 9C5 is nothing but 9C4. Now 2C1 is nothing but 2. 5C5 is nothing but 1. And 9C4 is 9 multiplied by 8 multiplied by 7 multiplied by 6 divided by 4 factorial. Now on solving this we get 126. So now we have 2 multiplied by 126, which is 252. So the total number of ways of selecting the cricket 11 is 840 plus 252, which is 1092. So there are 1092 ways of selecting the cricket 11, so that there is 1 wicket keeper and at least 4 bowlers. So the correct answer is option D, 1092. A group of 10 representatives is to be selected out of 12 seniors and 10 juniors. In how many different ways can the group be selected if it should have at least one senior? Here you are given 5 options and you have to find out which of these options is the correct one. Now here a group of 10 representatives has to be selected such that the group has at least one senior. At least one senior means a minimum of one senior. So the group of 10 representatives can have a minimum of one senior. Now since there are 12 seniors, the group of 10 representatives can have a maximum of 10 seniors. Now, if you follow the method of finding the number of ways where the group of 10 representatives can have uh, one senior and 9 juniors, or the group of 10 representatives can have 2 seniors and 8 juniors, and so on, till the group of 10 representatives can have all 10 seniors, is going to be very cumbersome. That method is going to be very long and cumbersome. Instead of that, solve this problem using this formula. Total number of ways of forming a group that consists of at least one senior is equal to total number of ways of forming a group of 10 representatives minus total number of ways of forming a group that consists of no seniors. Now first let's understand the meaning of this formula. Now total number of ways of forming a group of 10 representatives includes both seniors and juniors. The total number of ways of forming a group that consists of no seniors means this group consists of only juniors. So seniors plus juniors minus juniors will give us seniors. So finally, we'll get the total number of ways of forming a group that consists of at least one senior. So the formula is total number of ways of forming a group that consists of at least one senior is equal to total number of ways of forming a group of 10 representatives minus total number of ways of forming a group that consists of no seniors. Hope you have understood the formula here. Now first let's find out the total number of ways of forming a group of 10 representatives. Now it's given that there are 12 seniors and 10 juniors. So the total number of people is 22. Now the total number of ways of forming a group of 10 representatives out of the total number of 22 people is given by 22C10. Now let's find out the total number of ways of forming a group that consists of no seniors. Means we have to find the total number of ways of forming a group that consists of only juniors. So that group should consist of 10 juniors, and these 10 juniors have to be selected from the total of 10 juniors. So the total number of ways of forming the group that consists of no seniors is 10C10, which is one way. Now substituting these two values in the formula here, we get the total number of ways of forming a group that consists of at least one senior is equal to 22C10 minus 1. So the correct answer is option D, 22C10 minus 1. For a course, a student has to opt for 2 subjects out of 5 subjects, namely Commerce, Economics, Statistics, Mathematics 1 and Mathematics 2. Mathematics 2 can be offered only if Mathematics 1 is also opted. Find the number of different combinations of the 2 subjects which can be opted. Here you are given 5 options and you have to find out which of these options is the correct one. So here it's given that there are 5 subjects: commerce, economics, statistics, mathematics 1 and mathematics 2, and a student has to opt for 2 subjects out of these 5 subjects. But there is a condition given here. Mathematics 2 can be offered only if mathematics 1 is also opted. This means that if the student opts for mathematics 2, then he has to opt for mathematics 1 as the second subject. Now let's find out the number of different combinations of the 2 subjects which the student can opt. Now, the number of different combinations of the 2 subjects which can be opted by the student is either by not opting for mathematics 2 or by opting for mathematics 2. Now remember that OR means addition. So the student has uh, 2 options. He can either choose mathematics 2. He can either choose mathematics 2 as one of the subjects, or he can uh, opt out of mathematics 2. That is, he can select any other 2 subjects other than mathematics 2. Now let's look at the case where the student does not opt for mathematics 2. So if mathematics 2 is not opted, then the student can select 2 subjects out of the remaining 4 subjects: commerce, economics, statistics and mathematics 1. So the number of ways in which 2 subjects can be chosen out of 4 subjects is given by 4C2, which is nothing but 4 multiplied by 3 divided by 2 factorial. On solving this, we get 6. Now, if the student opts for mathematics 2, then according to the given condition in the problem, the second subject he can opt for is mathematics 1. So, if he opts for mathematics 2, he cannot opt for commerce, economics or statistics. He has to choose mathematics 1 as the second subject. So, there is only one way in which these 2 subjects can be chosen. So if mathematics 2 is not opted, then the number of ways in which 2 subjects can be chosen is 6. If mathematics 2 is opted, then there's only one way of choosing the 2 subjects. So total number of ways of choosing the 2 subjects is 6 plus 1, which is 7. So there are 7 different combinations of 2 subjects which can be opted by the student. So the correct answer is option C, 7. A selection is to be made for 1 post of principal and 2 posts of vice principal. Amongst the 6 candidates called for the interview, only 2 are eligible for the post of principal, while they all are eligible for the post of vice principal. Find the number of possible combinations of selectees. Here you are given 5 options and you have to find out which of these options is the correct one. So it's given that 6 candidates have been called for the interview for 1 post of principal and 2 posts of vice principal. So a selection is to be made for 1 post of principal and 2 posts of vice principal. Remember, and means multiplication. Now it's given that among the 6 candidates called for the interview, only 2 are eligible for the post of principal. So number of ways of selecting one candidate out of 2 candidates for the post of principal is given by 2C1, which is nothing but 2 ways. Now it's given that all the candidates are eligible for the post of vice principal. Now there are 2 posts of vice principal. Now after the selection of one candidate for the post of principal. Now only 5 candidates are remaining for the post of vice principal. So the number of ways of selecting 2 candidates out of these 5 candidates for the post of vice principal is given by 5C2, which is nothing but 5 multiplied by 4 divided by 2 factorial. 2 factorial is 2, and on solving this we get 10 ways. So there are 2 ways of selecting for the post of the principal, and there are 10 ways of selecting for the post of vice principal. So the number of possible combinations of selectees is 2 multiplied by 10, which is 20. So there are 20 possible combinations of selectees. The correct answer is option, but when you look at the options, 20 is not one of the options given. So the correct answer is option E, none of these. There are 5 tasks and 5 persons. Task 1 cannot be assigned to either person 1 or person 2. Task 2 must be assigned to either person 3 or person 4. Every person is to be assigned one task. In how many ways can the assignment be done? Here you are given 5 options and you have to find out which of these options is the correct one. So it's given that there are 5 tasks and 5 persons, and every person is to be assigned one task. It's also given that task 2 must be assigned to either person 3 or person 4. Remember, or means addition. So here you have 2 cases. In case 1, let's assume that task 2 was assigned to person 3. In case 2, let's assume that task 2 was assigned to person 4. So you have 5 tasks, and this is case 1 and this is case 2. Now let's look at case 1 first. Now in case 1, task 2 has been assigned to person 3. So person 3 has been selected for task 2 in one way. Now it's also given that task 1 cannot be assigned to either person 1 or person 2. So task 1 cannot be given to person 1 or person 2, and person 3 has already been assigned with task 2. So the persons remaining now are person 4 and person 5. So one person has to be selected from these 2 persons for task 1, and this can be done in 2C1 ways, which is nothing but 2 ways. Now, one person has been selected for task 1, one person has been selected for task 2. So for task 3, there are only 3 persons available. So here, one person has to be selected out of these 3 persons for task 3, and this can be done in 3C1 ways, which is nothing but 3 ways. Now, since one person has been selected for task 1, one person for task 2, and one person for task 3, now for task 4, only 2 persons are available. So one person has to be selected out of these 2 persons for task 4, which can be done in 2C1 ways, which is nothing but 2 ways. Now for task 5, only one person is available. So this one person can be selected in one way. So totally the number of ways in case 1 are 2 multiplied by 2 multiplied by 1 multiplied by 3 multiplied by 2 multiplied by 1, which is nothing but 12. Now let's look at case 2. In case 2, task 2 has been assigned to person 4, and this can be done only in one way. Now since it's given that task 1 cannot be assigned to either person 1 or person 2, and person 4 has already been assigned with task 2. Now the only 2 persons remaining are person 3 and person 5. So For task 1, one person has to be selected out of these two persons, and this can be done in 2C1 ways, which is nothing but 2 ways. Now that one person has been selected for task 1, one person has been selected for task 2. Now for task 3, only 3 persons are available. So for task 3, one person has to be selected from these 3 persons, and this can be done in 3C1 ways, which is nothing but 3 ways. Similarly, for task 4, only 2 persons are available, and one person has to be selected out of these 2 persons for task 4, and this can be done in 2C1 ways, which is nothing but 2 ways. And finally, there's only one person available for task 5, and he can be selected only in one way. So the number of ways in case 2 is 2 multiplied by 1 multiplied by 3 multiplied by 2 multiplied by 1, which is 12. So there are 12 ways in case 1 and 12 ways in case 2. So the total number of ways is 12 plus 12, which is 24. So totally there are 24 ways in which the assignment can be done. So the correct answer is option C, 24. A two-member committee comprising of one male and one female member is to be constituted out of 5 males and 3 females. Amongst the females, Mrs. A refused to be a member of the committee in which Mr. B is taken as the member. In how many different ways can the committee be constituted? Here you are given 5 options and you have to find out which of these options is the correct one. Now it's given that out of 5 males and 3 females, a two-member committee comprising of one male and one female member is to be constituted. So one male can be selected from 5 males in 5C1 ways, which is nothing but 5 ways. One female can be selected from 3 females in 3C1 ways, which is nothing but 3 ways. So the total number of ways is 5 multiplied by 3, which is 15. But it's given that Mrs. A refuses to be a member of the committee in which Mr. B is taken as the member. So out of these 15 ways, one way is not possible where Mrs. A and Mr. B are together in the committee. So the total number of ways that a committee can be constituted is 15 minus 1, which is 14 ways. So there are 14 different ways that a committee can be constituted. The correct answer is option C, 14. A college has 10 basketball players. A 5-member team and a captain will be selected out of these 10 players. How many different selections can be made? You're given 5 options here and you have to find out which of these options is the correct one. Now, the total number of ways of selecting a 5-member team and a captain is equal to the number of ways of selecting the 6 players out of 10 players and the number of ways of selecting the captain from these 6 players. Remember, and means multiplication. Now, a team of 6 members has to be selected from the 10 players. This can be done in 10C6 ways. Now 10C6 can also be written as 10C 10 minus 6, which is 4. That is 10C6 can be written as 10C4, and 10C4 is nothing but 10 multiplied by 9 multiplied by 8 multiplied by 7 divided by 4 factorial. 4 factorial is 24, and on solving this we get 210 ways. Now that the 6 players have been selected, any one of those 6 players can be the captain. So the captain can be selected from these 6 players in 6C1 ways, which is 6 ways. So the total ways the selection can be made is 210 multiplied by 6, which is 1260. So the correct answer is option A, 1260. In how many ways can a mixed doubles tennis match be played with players selected from 8 married couples such that a husband and wife do not play in the same game? Here you are given 5 options and you have to find out which of these options is the correct one. Now it's given that there are 8 married couples. This means there are 8 men and 8 women. In a mixed doubles match, there is one man and one woman in one team and another man and another woman in the other team. So totally in a mixed doubles match, there are 2 men and 2 women. First, let's look at the selection of 2 men. Now 2 men can be selected from 8 men in 8C2 ways. Next, let's look at the selection of 2 women for the match. Now it's given that a husband and wife do not play in the same game. This means the wives of the 2 men who have been selected cannot play in the same game. So out of the 8 women, now we are left with only 6 women. So selection of 2 women out of 6 women can be done in 6C2 ways. Now, if M1, M2, W1, W2 are respectively the 2 men and 2 women chosen for the teams, then the teams can be formed as M1, W1, M2, W2 or M1, W2, M2, W1. That is, the teams can be formed in 2 ways. So, number of ways in which the game can be played is equal to 8C2 multiplied by 6C2 multiplied by 2. Now 8C2 is nothing but 8 multiplied by 7 divided by 2 factorial multiplied by 6C2, which is 6 multiplied by 5 divided by 2 factorial multiplied by 2. We know that 2 factorial is 2 and on solving this we get 840. So the number of there are 840 ways in which the game can be played. So the correct answer is option A, 840. In how many ways can 3 consonants and 2 vowels be selected from the letters of the word triangle? Here you are given 5 options and you have to find out which of these options is the correct one. Now the word triangle contains 5 consonants T, R, N, G and L and 3 vowels I, A and E. Now we have to select 3 consonants and 2 vowels. Now 3 consonants can be selected from 5 consonants in 5C3 ways and is multiplication. And 2 vowels can be selected from 3 vowels in 3C2 ways. Now we can find the value of 5C3 multiplied by 3C2 either using the formula method or the shortcut method. Let's look at the formula method first. 5C3 multiplied by 3C2 is nothing but 5 factorial divided by 3 factorial multiplied by 5 minus 3 factorial, which is 2 factorial. So we have 5 factorial divided by 3 factorial multiplied by 2 factorial. 3C2 is nothing but 3 factorial divided by 2 factorial multiplied by 3 minus 2 factorial, which is 1 factorial. So we have 3 factorial divided by 2 factorial multiplied by 1 factorial. Now we know that 5 factorial is 120, 3 factorial is 6 and 2 factorial is 2. On solving this we get 10 multiplied by 3 factorial is 6, 2 factorial is 2 and 6 by 2 is nothing but 3. So now we have 10 multiplied by 3, which is 30. Now let's look at the shortcut method. 5c3 multiplied by 3c2. Now 5c3 is nothing but 5 multiplied by 4 multiplied by 3 divided by 3 factorial multiplied by 3c2, which can be written as 3 multiplied by 2 divided by 2 factorial. Now we know that 3 factorial is 6. So on solving this we'll get 10, and here 2 factorial is 2, and on solving this we get 3. So 10 multiplied by 3 is 30. So there are 30 ways in which 3 consonants and 2 vowels can be selected from the letters of the word triangle. So the correct answer is option E, 30. Out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? Here you are given 4 options and you have to find out which of these options is the correct one. So first here, out of the 7 consonants and 4 vowels, 3 consonants and 2 vowels have to be selected. So since selection is being done here, the concept of combination has to be used. Once the 3 consonants and the 2 vowels are selected, then we have to find out the number of ways of arranging these 5 letters among themselves. Now here, since arrangement is being done, the concept of permutation has to be used. So to solve this problem, the concept of both permutation and combination has to be used. Now first let's find out the number of ways of selecting 3 consonants and 2 vowels. Now 3 consonants can be selected out of the given 7 consonants in 7C3 ways. And is multiplication, and 2 vowels can be selected out of the given 4 vowels in 4C2 ways. Now 7C3 can be written as 7 multiplied by 6 multiplied by 5 divided by 3 factorial multiplied by 4C2. 4C2 can be written as 4 multiplied by 3 divided by 2 factorial. We know that 3 factorial is 6. So the 6 in the numerator and the 6 in the denominator gets cancelled. 7 multiplied by 5 is 35. We know that 2 factorial is 2. So on solving this, we get 6. So 35 multiplied by 6 is 210. So there are 210 groups, and each group contains 3 consonants and 2 vowels, that is 5 letters. Now let's find out the number of ways in which these 5 letters can be arranged among themselves. Now the number of ways of arranging 5 letters amongst themselves is equal to 5 factorial, which is 120. So the required number of words is equal to 210 multiplied by 120, which is 25,200. So 25,200 words of 3 consonants and 2 vowels can be formed out of the given 7 consonants and 4 vowels. So the correct answer is option A, 25,200. Viewers, please go through this video till you have understood the concept. Please do watch all our videos on combinations for better understanding. Please do watch our video on solved problems on combinations part 2. If you have liked this video, please like, subscribe and share this video. Thank you.